So I just walked through this problem on LeetCode. This is converting Roman numerals to integer. And interestingly, I observed a pattern where very little optimization in terms of how we store and access variables can really improve the efficiency of our algorithm. And I wanted to briefly share that. So this runs optimally because I am using a hash table and my lookup for values, the Roman numeral equivalent values, happens in constant time. So overall, my algorithm runs in on of n time, but the space efficiency is not very optimal. So I was quite surprised initially before I found this out to see that even when I had the optimal solution, in terms of overall performance, it was still way down here. So I looked at what optimization I could do, and I realized that this should mostly be in terms of the previous value I used. So because I assumed there could be a case at the start where there is no previous value, I decided to go with a previous value of none, and then I would have to check if there's a previous value, and then I have to compute the previous value and go from there. But this is not very optimal. I see a situation where since the previous value is only being used once, I don't have to run this check that checks for it at every iteration of this loop. That is not very efficient. So I see a situation where I could entirely remove what is happening with the previous value. So instead of having it as a string, I would totally remove this and I would replace this with a value of zero. So now I'd be worrying about the integer value, the number value of this preval, right? And then what I'm going to do here is instead of having double lookup into my hash table, I would only need to compare whatever I get from my hash table to the integer value of the previous value. So I have this. I would also come down here and instead of setting the previous value to the Roman numeral equivalent, I would rather set it to the integer value of that Roman numeral. So I'll do this to change that. So what I have so far is now that the previous value is always going to be an integer. So I'm going to run this to see if it runs. All right, I have a runtime error. It was a spelling error, obviously. Let me run this again. All right, so the solution was accepted. Now I'm going to submit to see how well it performs. And beautiful. Can we see that there's been an efficiency gain in terms of the solution? The runtime has improved, and overall, there has been much more space saved. So, very little optimization in terms of how we save variables, how we store variables could really improve the efficiency of our algorithms.